Focus this lesson on navigation. Prep and procedures. Prep and procedures. The fundamentals of getting from point A to point B. Step 1. Putting some procedures between us and the ground. Fundamentals of getting. Alright, we're off. Now keep climbing around the airport till we reach 5,800 feet. It goes without saying, but good navigation starts with good departure prep. Let's set up the aircraft for the first leg of your trip. Attitude? Check. Now, when you need to set and maintain a heading, you'll want to rely on your heading indicator. Compasses are prone to errors, especially during turns or while accelerating or decelerating. Go ahead and position your plane above the airport. Departure prep. We need to validate the time. That's a fancy way of saying start the clock. one more stop, Flagstaff Pulliam Airport. An easier way to navigate is to follow identifiable landmarks like highways. And just so happens we have one below us. On the nav log, you can see our next waypoint, Munns Park, is at a 41-degree heading about 5 minutes away. Navigating is basically flying a given heading for a given amount of time. Sometimes you deviate, but if you track the time flown from your last known position, you'll always have at least a range for your current position. We all know speed can increase or decrease depending on the wind. That's why at your next waypoint you'll want to compare your estimated time en route with the actual time flown. Validate your estimate and your progress. on Flagstaff Pulliam airspace. Next step is setting up to enter the traffic pattern. We've got clearance to enter the downwind leg and land on runway 21. Keep your attitude, then follow the standard pattern. altitude while maintaining cruise attitude. Finally, a landing on runway 21, and we'll call this one done. Successful VFR flight in the books. Not bad. Not bad at all. Are you ready for this? You are going solo on a full VFR flight. You'll be departing Flagstaff Pulliam Airport, handling every navigational step on your way to Sedona. From takeoff to touchdown, it's all you. Don't worry though, even if I'm not with you in the cockpit, I'm always with you in spirit.
Hey, this is Kip, and in this video, we're going to learn about VORs and how to navigate using them in Microsoft Flight Simulator 2020. So first of all, what is a VOR? Well, it stands for VHF Omnidirectional Range. Sounds like a lot, but VHF part is just the specific range of frequencies that the VOR transmits on. VHF. You may have heard that before from things like analog television signals, FM radio signals, and so on. VORs just happen to use that same range of radio frequencies. And the O in VOR stands for omnidirectional. That means just in all directions. So this equipment, the VOR, it actually emits in 360 degrees, and we can use these radio frequencies, tune into them, and the equipment inside our aircraft will let us fly to and from these VORs on a specific heading. And here on skyvector.com, I have the world VFR map pulled up. And this blue compass rose represents the area around a VOR. So whenever you see this blue compass rose, you know that a VOR is in the middle of it. So here's one here called the San Marcos VOR near Santa Barbara. Over here to the west, we have the Morro Bay VOR that's next to the San Luis Obispo Airport. Then over here, we have the Fellows VOR. This is on a mountain range over here and is not specifically next to any airport. So let's talk about how a VOR works in terms of navigating. So the easiest way to think about VORs is to think about them as a giant wheel. And the center of the wheel is the VOR itself, but the radio transmissions coming from the wheel are the spokes. And there are 360 spokes coming from the center, radiating from the center. And we call those each a radial. And you can think of each one of these spokes almost like its own highway. And you can choose to fly on one of these if you want to, from the VOR or to the VOR. So let's pretend that we're flying from the exact center of the wheel, the Fellows VOR, on a 090 heading with no wind. We would say that we are tracking the 090 radial outbound, which means from the Fellows VOR. We could also turn around and fly from the outside straight to the Fellows VOR, tracking the 090 radial inbound. So if our plane is located here, which radial are we on? Okay, well, we draw the line. Okay, we're on the 030 radial. Cool. What if our plane is over here, but we're heading west? What radial are we on? Well, we're still on the 300 radial. We just happen to be flying to the west. That doesn't mean that we're not on the radial. We may be choosing to not track the radial out or inbound, fly perfectly on that spoke or highway plan, and that sets it as our destination. This line here here, the magenta line, this represents what we would fly if we were just doing a direct route using GPS. So how do we navigate this using VORs? Well, we know that VORs have a limited range, and we know what we can do with VORs is fly precisely to one of them on a specific radial that leads to or from the VOR.
Zero 80 at 14. Have our TCAS alive, and yeah, I don't know. I don't think I need to put CBDLC. I don't know. We can give that as information, whatever. 28,000. That is all correct, and file. Alright, flight plan is also been filed now. Alright, let's announce that we're gonna be leaving. Tráfico Bogotá, aquí Láser 903 con plan de vuelo hasta Maiquetía, Caracas, Simón Bolívar. Estamos finalizando nuestro preparación.
VOR. So I'm going to go ahead and first pick this VOR right next to us. Morro Bay VOR is right next to the airport we're departing from. We will definitely be able to tune into it and be within range from it. And then we can see that if we just use that one VOR, we could potentially get all the way to Santa Barbara just by flying the 121 radial from the Morro Bay VOR and flying on that for 67 miles, and then we would see the Santa Barbara airport. Now, tracking 67 miles might be challenging. It's nice to have some more points that we get to. So I would like to just add another point so we know when we get close enough to Santa Barbara. And this also will make it a little safer for us in the case that we lose the signal of the Morro Bay VOR. 67 miles doesn't sound like a lot if we know that they can work for up to 150 or 200 miles. But say I'm not super familiar with the terrain, or I've never used the VOR all the way to Santa Barbara. So what I could do to be safe is just add another VOR to my flight plan. So I'm going to pick the Gaviota VOR and then go ahead and hit plan there as well. So in SkyVector, sometimes it'll pick like a departure for you, a departure procedure. I don't want that, so I'm double clicking on this VLUF and I'm removing it to make sure that it doesn't try to use that. And then this T261 also got added. I'm going to get rid of that as well and hit enter. And you can see that it brings back this calculated course of 126 degrees, and that represents the 126 radial that will fly outbound from the VOR. Step 1 is to depart from San Luis Obispo and tune into the Morro Bay VOR. So that is 112.4, and we're going to set that up in our navigation radio. We're going to take the 126 radial outbound. So we're going to fly outbound on the 126 radial until we get in range of the Gaviota VOR. Now, once we get in range of the Gaviota VOR and pass it, we want to fly outbound on the 101 radial, and that'll take us directly to Santa Barbara. So this is the flight plan we're going to start with. We're going to load in using 52, and if you haven't seen and we're going to fly this. All right, so here we are at the San. There's no navigator. And we're going to use the navigation radio number 1, which is coupled to this instrument right here, which is called the CDI, or Course Deviation Indicator. So the first thing we're going to do is put in the 2 radio frequencies we'll be using on this flight, and those 2 are the 2 VOR nav frequencies. So right here, we're going to put in the Morro Bay VOR. That's the first one we're going to use as we leave the San Luis Obispo area. And so now to swap to that frequency and make it active, you just hit this little swap button right here. That'll move standby to the active frequency. And as soon as we do that, you'll see the CDI change. The needle has moved to the left. It now says nav, and it's lit up right here. And then this little flag shows up, this little arrow that says from on it. And we'll get into what that means in just a second. But first, let's go ahead and change our standby frequency to the second VOR we're going to use, which is the Gaviota VOR. So we put 113.8 in our standby frequency right here. So back in SkyVector, if we remember up here, we had moved this waypoint out here, 8, and our standby frequency right here, 3.8, and our standby frequency right here. So back in SkyVector, if we remember up here, we had moved this waypoint out here just so we could see the radial more clearly. And actually, if we move it out of the way, we can actually see that this teal line right here actually also refers to the 126 radial. And that's because that's drawn between the VORs. That's drawn between the Morro Bay VOR and the Gaviota VOR. So they're showing us our reference. For our reference here, conveniently, it's showing us those radials. So now 126, how do we define that? Well, there's a knob right here on the CDI called OBS, and that stands for Omni Bearing Selector. So that means you can select any bearing using this. And we're going to go ahead and twist this until the 126 radial is at the top, where this yellow arrow is pointed to. So when you first start turning this, and I'm turning it with my mouse wheel, it's going to jump 10 degrees at a time. If you click it, it'll also jump 10 degrees at a time. Sometimes it'll go 1, but most of the time it seems to jump 10. To get it to go 1 degree at a time, the only option right now is to click and hold. So when I click and hold, it's going to jump 10, but then it's going to keep turning in smaller increments. So because we want a 6 at the end, I'm just going to turn it until we get to a 6, just to set that up, and then we'll turn it 10 at a time after that. So I'm going to click and hold, and then let go when it's right around the 6. I think I can get it a little bit closer. There we go. So that's probably a 6 right there. And now that I have the 6 dialed in, I can dial in the 1, 2. So it's 1, 2, 6. So now I'm just going to use my mouse wheel and keep scrolling until I get to 1, 2, 6. So 1, 2, 6 right there. So that's pretty precise. So now so that's probably set 6 right there. And now that I have the 6 dialed in, I can hold and then let go when it's right around the... And now that I have the 6 dialed in, I can dial in the 1, 2. So it's 1, 2, 6. So now I'm just going to use my mouse wheel and keep scrolling until I get to 1, 2, 6. So 1, 2, 6 right there. So that's pretty precise. So now we've defined the radial that we want to use, and basically when we start flying, this needle right here will reflect if we are on course or not. So if the needle is to the right, we need to fly to the right, and if the needle is to the left, we need to fly to the left. So we'll do more on that once we get flying, but I'm going to go ahead and set my altimeter, and then I'm going to take off and we'll be on our way. All right, we have 40, 45, 50, and rotate. All right, we're up. Airspeed's good. We're going to keep going. Pitch for 75 knots. There we go, 75, looking good. All right, continue for south departure. So now we're able to make our turn, and we want to turn to 120. It's directly behind us. Go ahead and turn to the left to get out there. So now that we've taken off and we have the 126 radial set in our OBS, we want to track that radial outbound. So the first step is to turn to fly a heading of 126. So that we'll be flying parallel to the radial that we want to track. Okay, so now that we're at 120 or 126 roughly, and we see that the needle right here is to the right, we know that the radial is to our right. So we're flying parallel to that radial right now, but we want to intercept the radial. So now that we've been parallel, we're going to turn to intercept. And we generally do that at a 45-degree angle. So now we're at 45 degrees because right here, see this little notch right here, we have the 126 marker right on that. So that means we are heading at a 45-degree angle to it. And so now what we'll watch for is for this needle right here on the CDI to come in to the center. And before it gets all the way to the center, we kind of want to roll back to that 126 heading, so we don't overshoot it. But if we do overshoot it, we'll just turn right, and then we'll be going right back towards the needle. We'll just make small adjustments. And you'll see that you have to make those small adjustments throughout the flight. And it's nice to be at a 45-degree angle just because you really limit how fast that needle will move in. You want it to be coming in slow enough so that you can react to it. And like it is right now, since it's coming toward the middle, I'm going to start banking to the left again to slow it down ever so slowly as it gets towards the middle. We want to make it so when it gets to the middle, we are on that 126 heading. That's how we'll make sure to not overshoot it. So it's coming in pretty quick now, so I'm going to make sure to bank a little more. Get over towards that 126 heading down here on our heading indicator. It's pretty centered, so I'm going to go and turn us left to that 126 heading. And we're just going to try to hold that heading. And now because there's winds, wind will be pushing us left or right, slightly off course, we'll have to make small adjustments as we fly. So just keep your eye on the needle and make sure that we're actually going on the right course. All right, so now that we're on route, let's talk about the to and from flag that shows up on the CDI right here. So because the CDI shows the needle in the middle, that means that we're tracking the radial. It shows a from flag because we are on a radial outbound from the VOR. We're heading from the Morro Bay VOR on the 126 radial. And we know we're on that radial because we've tuned the CDI to have the radial at the top. We're at the 126 radial at the top here. And when the needle is centered, that means that we are tracking that radial and we're on that course. Now what I'm going to do is go ahead and change our frequency over to the Gaviota VOR, which is the one we're headed to. And when we change it, take a look at what happens to the CDI. I'm going to go ahead and switch the frequency right now. And it reset, and now it's back on. So you may have noticed that the needle shifted a little bit more to the middle. The reason for that is that it's so much further away that it's less precise. So it's less sensitive. As we get closer and closer, it's going to waver more to the left and right and be harder to keep in the middle the closer we get. Until eventually, when we pass over the VOR, it'll go really hard to one side, and then it'll come back into the middle. And you may have also noticed that the flag now flipped to say 2. And that's indicating that we're heading towards the VOR, not away from it. So we're on the same heading, and we're on the same track that we're following because we're basically drawing a straight line, our flight plan, from the Morro Bay VOR down to the Gaviota VOR. So of course, we're still right on track. When we were flying outbound from the Morro Bay VOR, we were actually on the 126 radial. Remember that you can think of them as kind of physically being in that location. Now that we've switched over to the Gaviota VOR, we need to talk about things in relation to the Gaviota VOR's radials. And we are not on the 126 radial of the Gaviota VOR. And that's because the 126 radial from the Gaviota VOR is located here at a 126 heading from the VOR. So what radial are we on right now? Well, if you just look at the one that's on the opposite side, that's the radial we're on right now. We're not on the 126, we're actually on the 306. So we can't possibly be on the 126 radial because the 126 radial is southeast of Gaviota VOR. What we need to remember is that when the 2 flag is shown and the needle is centered, we look at the bottom of the CDI to know what radial we were on.